So welcome back friends, welcome in another video of enzyme kinetics. So today we will going to talk about the Vmax. In the previous video we have completed our discussion on Km. So now it is time for Vmax. So before going to talk about this video, I would like to recapitulate a equation that we have discussed during the derivation of the Michaelis-Menten equation, that was V0 is equal to K2 into enzyme substrate concentration, right? And I have also told in that video that when we will talk about the Vmax, this equation will change into Vmax is equal to K2 ET. Why? Because the velocity of the reaction will be high only when all the active side of the enzyme are fulfilled with substrate, right? So under such circumstances we can equal enzyme substrate concentration with the total enzyme concentration, because remember friends, we have already discussed that ET is equal to ES plus E, where E is the free enzyme concentration, and at maximum velocity there will be no free enzyme available, and as a result we will only end up with this relation. Okay, and that is why Vmax will be is equal to K2 ET. Okay, so here Vmax is the maximum velocity and ET is the total enzyme concentration. Okay, now this rate constant K2 is known as here the turnover number. Okay, you may heard about the term turnover number in earlier times. So this turnover number is the number of the enzyme which can convert number of the substrate molecule into a product in unit time. Okay, what does it mean? It means that it is the number of the substrate molecule that can be converted into product by an enzyme in unit time. Okay, when enzyme is fully saturated with substrate. Okay, that means K2 will be the turnover number when we are talking about the Vmax. Okay, and what is the definition of the turnover number? Turnover number is the number of the substrate molecule that can be converted into product by enzyme in unit time. Clear? When enzyme is fully saturated with substrate. Okay, so with the help of the above equation we can easily calculate turnover number of an enzyme if we know the value of Vmax. For example, here I have taken a mathematical problem. So if 10 to the power minus 6 molar solution of enzyme catalyzes the formation of 0.6 m product per second when it is full saturated, that means 10 to the power minus 6 is the total enzyme concentration. Okay, and this one is about Vmax. So they want from you about the KT, your K2. Okay, not KT, sorry for that. They are wanting the value of K2. Okay, so you can easily calculate it. For another, for example, there is another MCQ, that is what is the turnover number or Kcat, or you can also call turnover number as Kcat or K2, both are same, for an enzyme catalyzed reaction which has a maximum velocity of 3.47 moles liter inverse minute inverse. So it is the value of Vmax when the enzyme concentration is 6.85 10 to the power minus 1, that is the value of ET, and molecular weight of the enzyme is 12,800. That means we have to take in the ET as 6.85 into 10 to the power minus 1 divided by 12,800. Okay, and then we also know about the value of Vmax, so we can easily calculate about K2 or Kcat. Okay, now I think that you guys also may have some problem when you get two value together, that is enzyme concentration and molecular weight, because I have also that problem. So whenever you don't know what to do with this kind of molecular weights, then I would like to share you something, that is, although here I have not mentioned the option, if I will, then you can understood this, that option has mentioned that the unit of our answer will be minute inverse. Okay, now let's try to think about this. If we simply divide 6.85 and 3.47, sorry, it will be a multiplication, so if we simply multiply them, then our value will never be minute inverse, right? But if we first divide 6.85 into 10 to the power minus 1 and 12,800, and then multiply them with 3.47, then we can get our value. Okay, so that is the thing with the help of which you can easily calculate things. Okay, so this is the end of this video. So I hope this video will be helpful for you. So thank you for listening to this class. We will going to solve many another type of MCQ question when we will going to practice our concepts on enzyme kinetics. Before that, we have to complete the syllabus first. We'll have left still Lineweaver-Buck plot, then the Eddy-Hopsey plot, then we will going to solve some questions from the enzyme kinetics. So till then friends, bye bye.